I'm Josh Angelchick, Senior Data Scientist at Ironside Group, and I'm here to talk about how an organization becomes data-driven. On the agenda for today, I'll first touch on who we are at Ironside. Then I'll shift into the meat of our conversation by first defining what it means to be data-driven, as well as lay out an organizational blueprint for success. Lastly, I'll touch on the recent proliferation we're seeing in low-code, no-code tools, particularly within the AWS ecosystem, how we're using them to derive efficiencies internally, and how our customers are reaping the benefits. So we at Ironside have been in the data and analytics space for over 20 years. You'll note we do provide end-to-end services, so we can take a holistic approach to our client projects, but we're really here to engage customers wherever they are in their journey. So if you're starting from scratch with strategy and use case discovery, that's fantastic. Maybe you have some existing infrastructure that you'd like to expand, or perhaps you're finally ready to take that leap into productionalizing some AI and ML projects. We're here to help for all of the above. Here's some eye candy on some recent projects we've done for clients. A real estate services company wanted a better pulse reading on their day-to-day transactions. A beauty products franchise wanted to better understand how their product mix performed across various stores. And a hair salon franchise wanted a more intelligent way to quote customer wait times. At its core, a data-driven organization is an empirical one. You take real-world data, you recognize patterns that exist in the data, and you use those to derive insights and inform business decisions. But it's not as simple as just taking a heap of data, plugging it into a dashboard or an ML model, and then at the end of the tunnel, you've got insights and actionable decisions waiting for you. You got to make sure you're dotting your I's and crossing your T's along the way. There are three really important domains in any data project. Firstly, you got to make sure you can get your hands on some data and store it. And that's where your data engineering team's going to come into the fold. And then you need boots on the ground and business subject matter experts who actually understand how to contextualize the numbers in the real world. And if you're looking to do any prediction or forecasting, any advanced statistics, that's where the data science team is getting involved. Now, individually, these three sub-organizations are super important and potent, but it's the interdependence and synergies where an organization can really derive a lot of business value. If you take shortcuts in any of those three verticals, you can undermine your ROI significantly, and you might even run the risk of misinforming your business decisions. A quick psychology 101 review for everyone watching. You may recognize this pyramid looks very similar to Maslow's hierarchy of needs. This is Maslow contextualized in a data science workflow. But the main takeaway from Maslow is that you cannot ascend the pyramid until you've fully satisfied all the criteria of a given step. So if we're starting from the bottom up, you need to get your hands on data if you want to be data-driven so that you can derive those insights. And then you need to build a pipeline. You can't refine crude oil without a pipeline to the refinery. So that's what we're doing with the data engineering team. Next, what I would argue is the cornerstone of any data project is the exploration and transformation phase. I know statistics tells us that there's no such thing as a 100% probability. I would argue the exception is that there's a 100% probability your data is messy in some way. Some ideas that come to mind are perhaps some point of sale data in which an employee accidentally fat fingered a zero where it needn't exist, or maybe they miscategorized a transaction. Well, when you plug in data with incorrect patterns, you're going to get incorrect business decisions from those models or dashboards that you develop. So this is of paramount importance. Once we have our house in order in terms of clean data, getting rid of any anomalies that might skew our insights, then we can go ahead and start developing those business insights. So in the BI space, we're looking at KPIs, perhaps some overarching segmentation or aggregate data exploration. And then as we hop into data science, we have things like regression and classification workflows, A/B testing. Perhaps you're a UX UI developer that wants to better understand how your website stimulates your clients. Data science is where that's going to happen. Again, we cannot ascend this pyramid until we have satisfied all of the criteria for a given step. And this is not in rank importance it is in sequential order. You need your data engineers as much as your BI analysts, as much as your data scientists. Organizationally, here's what a healthy interdependent flow of information looks like. So initially, the business decision makers are going to hand down requirements to the technical folks. Starting with the raw data, the data engineers are going to capture and store that data. They'll perform some transformations on the data that is unstructured or semi-structured residing in the data lake, and they'll send that to the data warehouse so that the data is consumable by both the dashboards the BI analysts are building, as well as the ML models the data scientists are developing. Now, the workflow does not end with the BI analysts crunching their numbers or the data scientists developing their models. You're not leaving a model in a Jupyter notebook to wither away. You need to send those outputs back to the data engineers so that they can then expose them for consumption by the business decision makers. You need to close this feedback loop. Insights have to make it back to stakeholders, and you need to iterate on your workflow. The technical folks, the data engineers, the BI analysts, and the data scientists, make sure that the data is moving intelligently. The business decision makers make sure, does this pass the smell test as those outputs arrive? And then they're taking action based on those insights. Now, when we're tackling an AI ML project at Ironside, there are a number of principal ideas we like to keep front of mind. The one I'd like to focus on here is the idea of de-risking your AI ML investment cycle. There's no shame in your data project failing so long as it fails early and it fails cheap. So starting with use case discovery, if we're honing in on a business question, we need to make sure that it's quantifiable. As we move to rapid viability assessment, we need to make sure we can get our hands on data to answer that question and that the data provides the signal we would expect to see in the real world. As we forge on to the machine learning development, if the model's lackluster by the time training is done, well, there's no sense in deploying it. So those decision gates we have at the end of modules 1 through 3 are to prevent ourselves from going on a wild goose chase and pivoting focus as needed. Now, provided we make it through the machine learning development phase and a model's performing in a satisfactory manner, it's time to cross the Rubicon and deploy it. The deployment needs to be integrated in an automated fashion with the business decision workflow. So ideally, business decision makers are only a few clicks of a few buttons away from deriving insights as needed. Module 5 can often be overlooked, but it's also incredibly important. You need to monitor that model. You're not going to have a completely representative data set of the population problem space that you're looking at. But as new data become available, you might notice that your model either suffers from decay or data drift. It's no cause for panic. You can use this to inform your retraining cadence. And you want to always be making sure that the KPIs and thereby the ROI are performing as expected. As I move on to talking about the low code, no code value proposition, I want to harken back to the organizational chart I showed a few slides prior. I believe a majority of the value proposition comes within the inter-team synergies that these tools enable. Firstly, they're lowering the barrier to entry in terms of functionality. Perhaps you're a lean team that has many data engineers, but not so many data scientists and BI analysts. Well, with tools like SageMaker Canvas or Autopilot AutoML, you can have your data engineers start getting their feet wet in machine learning. The same is true of QuickSight with respect to BI. In terms of cost, you're not going to have to dole out a bunch of money for new human capital if you want to expand the breadth of functionality on your team, if you're a lean team. And if you're a large enterprise, the efficiencies you can gain from these low-code, no-code tools are going to keep your man-hours labor costs down. Another really exciting thing that we're seeing these low-code, no-code tools do is bridge technical gaps internally. Because the business users and decision makers are able to get more involved in the technical day-to-day, it makes them a lot more appreciative of the work that the technical folks are doing. And it also allows them to see how a project is brought to life. The low-code, no-code tools make that workflow a lot more digestible for business users. Another big downstream benefit of lowering that barrier to entry from a functionality standpoint is how you drive efficiencies with respect to collaboration between teammates. In certain instances, you're actually going to increase the overlap between teams because the breadth of functionality within each team expands with these low code, no code tools. That doesn't mean one team is stepping on another team's toes. In fact, you just have more people involved in the problem solving process. It also avoids the conundrum of those overlapping tasks getting lost in the ether. For example, is data engineering or data science responsible for this particular query? Ultimately, what all of the above is going to do is accelerate your insight cycles. So you're going much more quickly from use case one to insights with respect to that use case to use case two and repeating the process. Another thing for me to note for all the technical people watching, low code, no code is not here to steal your job. I know that when I saw these tools coming to the forefront, I thought to myself, there goes all the time and money I've spent educating myself and specializing my skills. What I'm finding is that the scope of my work is changing. I'm not spending hours in the terminal writing code all the time now. I'm trading that legwork for quality assurance. Ultimately, you want everyone focusing on data quality because that is the corner piece of a healthy data project. To lend a bit of credence to the low code, no code value proposition I've just outlined, I want to touch on two customer stories. Firstly, we had an international sea freight company that wanted to predict the likelihood of their loads being audited and whether those audits would be successes or failures. The longer those loads wait at the dock while the paperwork is being processed, the more time and money that company is losing. Now, in an ideal world, they'd have the manpower and resources to be hyper-focused on the paperwork for every single load, but that's just not realistic. So leveraging machine learning, we were able to identify which loads were most likely to be audited, and by extension, the loads that they should most focus on in terms of paperwork. So we took all of their historical data with respect to shipping, bill of lading, and those audit outcomes. We built a near real-time pipelining solution so that we could make predictions in near real time. And this allowed the client to prioritize which loads they wanted to focus on in terms of the auditing paperwork. Where did low code, no code come into play? Well, this was one of those leaner teams that I was describing a few slides prior. They have a very robust data engineering practice. They want to get involved in data science, but they want to look before they leap and make sure they're doing it in a cost-effective manner and in a way that it's digestible for the whole team. So this low code, no code solution that we built using Data Wrangler and SageMaker Canvas allowed the customer to understand the workflow of the data science project without an extensive data science background. It also was convenient that they had come from a legacy drag and drop solution, very similar to SageMaker Canvas. However, they were really excited to see how much more robust the data science offerings were within Canvas. And lastly, we built out the pipelining solution in AWS, so Canvas seamlessly plugged in as a solution. Secondly, I'd like to talk about a national fitness franchise. They wanted to identify the most important factors in determining a franchisee's success, particularly with respect to annual member revenue per gym. The ML solution had two tiers. First, we segmented customers by their behaviors, things like class attendance and sales transactions. Then we categorized all of the franchise gyms based on the attendance groups from that customer segmentation, as well as features like square footage of the gym, location, so on and so forth. Now, this particular client is more nascent in their data journey. So here the significance of AWS low-code, no-code solutions had most to do with the benefits we at Ironside reaped internally. My personal favorite was the collaborative live pair programming and debugging in the low-code, no-code environment. It avoided duplicate work. It avoided headaches with Git. I was no longer on Zoom calls verbally debugging things, telling my coworkers how to correct a particular cell in a Jupyter notebook, and they could do the same with me. The use of the visual process editing, it mitigated the conventional version control headaches. And again, this company that we were working with is nascent in their data journey, but the workflow visualization demystified the ins and outs of the data project. And as opposed to being intimidated about furthering their data journey, they're eager for more. In sum, building a data-driven organization requires developing and maintaining multiple interdependent sub-organizations, your data engineers, your BI analysts, your data scientists, as well as those business decision makers, all working in unison. AWS low-code, no-code solutions enable organizations to become data-driven at a much quicker pace. You lower the barrier to entry in terms of functionality and cost. You're fostering communication and collaboration between teams and actually expanding overlap to your benefit. And thereby you're accelerating the solution development time. Some of our favorite AWS low-code, no-code products at the moment for the data engineering and infrastructure space involve Redshift and Glue. When I get to work in data science and ML, I love using Data Wrangler, SageMaker Canvas as well, and the Autopilot AutoML. And for BI, QuickSight is unrolling a lot of really impressive low-code, no-code solutions, particularly natural language querying in QuickSight Q. Thanks for your time.